Hello everybody. This is the second video with our effort to build a REST API using Phalcon version 6. In our previous video we actually set up the repository. We managed to install different dependencies using Docker Compose, using Composer, and we also created Docker Compose a Docker Compose YAML file with a Docker file that will allow us to enter our environments, whether this is 8.2, 8.3, or PHP 8.4, and would allow us to run different commands against these environments. So moving ahead with this, we just need to make sure that once the environment is up, we check the IP address, and then we're going to move ahead with our other tasks. And the reason we're checking the IP address is so that we can see whether hello world is being printed out on screen. So if you remember using the index.php, we just have hello world. So docker inspect REST API 8.2. The address is 172.21.04. Let's copy that address. And sure enough, we have hello world. What we're also going to do here, just to be on the safe side, is we're going to add a date here of year, month, date, and let's make it with dashes, and HIS. So once we refresh our page, we should see a date after that, and then as we refresh, the seconds count. The reason I'm doing this is just in case we have some sort of a cache issue and things are being cached on screen, we just know that this thing keeps on moving and it's refreshing. If you make a change and you expect to see hello world, you are going to see it, but you don't necessarily know that this comes from a cache or not. So what we're going to do now is going to start building this application. We have installed Rob Morgan's Finks. So what we need to do is we need to make sure that we have our migrations where we want them and where we need them. So what we're going to do is we're going to put them under resources, and to do so we're going to create a DB folder, and under that we're going to create two more folders, one for migrations and one for seeds. So let's do that. What we're also going to do is we're going to copy this git keep file just in case, so that we have the folders in our git, and it might not matter that much about the migrations for now, because we can create migrations and it will have certain files, migration files in it, but for now we'll just keep the git keep file there so that we make sure that the folder structure is created appropriately. So let's commit those two changes. Added migrations seeds path folders for things. Okay. So now these are all there. What we need to do is we need to create a Finks PHP file that would allow us to work with things. So let's go ahead and create it. Now I've already created the file, so I'm just going to copy and paste the contents. If I can find it. Yes, I found it. There you go. So what we're doing in this file is we're taking advantage of the .env library from VLOOKUS. We're also auto-loading everything with regards to the Composer autoloader. The environment here is a little bit different than what we would usually see in an application. What we're doing is we're getting everything from get env, as well as the $_env variable, or super global for that matter. We're merging those together, and then we're just keeping that in a variable. Then we load the .env file, which is this env file here, and then we're actually merging the .env super global with whatever we had before and just passing it to the env. The .env file, the .env library would actually load all the variables in our .env file inside the super global. So what we want to do is we want to make sure that we keep everything that was passed before and after, and just make sure that everything is in our environment. So the array that needs to be returned is that our migration is located in the resources DB migrations, and the seeds in the resource DB seeds. We just name our table ut_migrations. Default environment is development, and so on and so forth. For those that have worked with things, this is pretty much a standard configuration. So if I go here into one of the containers, the 8.2 container, and type things status, I will get there's no available migrations. Now I did connect to my database. The database has been defined, let's look at the env, as the rest-db, and that's the database that has been set by the Docker Compose file. So what we can do is we can create one migration just to create a users table, and we're going to work on that as we go along in this particular series of videos. So in order to create the migration, all we need to do is things create, add users table, and now the migration has been created. And if we go here to the migrations, you see that it's right here. Now things has this wonderful feature about the change method. It allows you to either move your database forward in terms of making changes or roll it back. I personally prefer to use the other two methods that they have, the up and down. So what I'm going to do is I'm going to create an up and then a down for that. There's nothing wrong with using change. That's my personal preference. And what I'm going to do is here is in the down, what I'm going to say is table equals this table co users, and then what we're going to do is we're going to drop it. Actually, we can do this in one line. Drop and then save. So this will be my rollback, which means that it will delete the users table going backwards. So it's going to bring the database exactly where we are, which means that we don't have a CO users table. But what we want to do now is we want to create a users table. So what I'm going to do here in the up is, let's say table equals this table, and then it's going to be a little bit different in terms of syntax, CO users, and then in the parameters, what we're going to do is we're going to say ID equals USR ID, and then the signed equals false. And after that, we need to do table, add column, and the first one will be the status. That one will be a boolean, because we don't keep a lot of numbers in the status column. It will be 1, 2, 3, and so on and so forth. And that will be signed equals false. We don't want it to be null. And the default will be 0. Now, I'm not going to bore you with the rest of the columns. I'm just going to copy them, paste them, and quickly go through them. And of course, we are going to make sure that we have everything that we need for this table as we move along. So let me copy the username and the password columns, and then the rest of them will come when we start talking about authentication and so on and so forth. So as you see here, we're creating a column called USR username. It's going to be a string limit 128, and the password, again, it's going to be a string limit 128. And those two cannot be null, so that's why we have null equals false. What we're going to do is we're going to add indexes for the columns, and the indexes are here. The way the workflow would go would be to search by username or to search by status flag. So I could potentially make this index a status flag comma username, so a compound where first of all you check the status flag and then you check the username. For now we can just leave it as is, but we're going to work on optimizing things a little bit later. So all we have to do here is save, and what this will do is it will create the user table, the CO users table for us. In order for us to check it, let me quickly do docker inspect rest db, and the rest db is 172.21.03. I need to copy this if I can select it, and then if I go to my database, and I'll make sure that I have this. Okay, apply. I already did some work for this, that's why you see all these, and if I refresh it, there's nothing in here. Okay, now I can run things status. I came back to my dockerized environment, and you see there is one migration that has not been run, and let's run migrate, and it just run. So let's refresh this. You see now we have tables, CO users, the columns that I've just mentioned, and the necessary indexes. So we have something for our database. So this is our first migration. Just keep the table, and let's commit this. Added migration for users table and things config. Right. So now what we need to do is we need to start working on this application and set up things the way we need to, right? In this application, we just want to start printing the hello world, but in order for us to do this, this is just a simple script. We need to start using Phalcon. So with Phalcon, we need to start by creating a DI container, a container that would allow us to have access to different services. So the easiest thing to do is to use the factory default, which has a bunch of services defined in it, but we don't really want to do that. We want to streamline it so that we don't have unnecessary services just laying around there. Not that it does matter a lot, because all those services are lazy loaded, so just the definition stays there, but just to be on the safe side, we want to have things nice and tidy. So what we're going to do here, we're just going to comment this out, and we're going to say container equals new DI. That's our main container. And then application equals new micro. And in this application, we're going to pass the container, right? And of course, you need to spell properly, application. Now, we also need to ensure, let me just take this out of here. We need to ensure that we have a loader. For now, let's use the auto loader that is provided by Composer. So in order to do that, all we have to do is require once up here. And there you go, a little bit of help from the autocomplete, and we got it. So this is going to be our main application. And in order for us to send something out, we need to be able to handle whatever URI has been given to us. So let us do that. We're going to say URI equals server request URI or nothing, and we want to make sure that this is a string. This is for the static analyzer. And then let's do application handle URI. Now, I don't expect to get much from this. Most likely we're going to get an error of services missing, but let's have a quick look. There you go. We have services missing. The service router was not found in the dependency injection container. So that's not the only service that will be missing. So let's go ahead and start putting the services into a container that we want to build. This application will be built using the ADR pattern. The ADR pattern is mostly a user interface pattern which splits the application to three distinct areas: the action, the domain, and the responder. In short, the action is some sort of a collector slash router. It's responsible for being invoked when the route is being presented, if you like, or requested by the user. Then it calls the domain, the service, with some information, most likely the input that was sent by the user. And then the service does its job. It returns whatever it returns, and then whatever has been returned, it's been passed into the responder, and the responder makes sure that it spits it out to the user. So that's the purpose of the action. The responder, in turn, is accepting data that came from the domain by means of the action, and then it does whatever it needs to do in terms of formatting. So a responder could very well be a text responder, just plain out text, or it could be a CSV, it could be JSON, it could be anything you want. And the domain is pretty much the whole business logic, what your application will be doing. This is, in layman's term, a quick definition of what the ADR pattern is. You're more than welcome to read a little bit about it. Paul M. Jones has a very good description on his GitHub, pmjones/ADR, I believe, and you can have a look at how it thinks wire and what is different between the ADR pattern and the MVC. The reason we're doing this is to showcase that Phalcon is not bound by one methodology of building an application, or one pattern, if you like. Although it is heavily influenced by the MVC pattern, it can actually handle different patterns as they come along, and you can just develop whatever you want to develop. Keep in mind that this is not the way of building an API. This is just a way. So you can either adapt or scrap or modify whatever I'm presenting here according to your own needs. I'm just trying to showcase what we can do. All right. So let us build our container. What we're going to do here in the SRC folder, we're going to create three distinct folders. As I mentioned, one will be action. Oops, that's the wrong place. We need to put it here. The second one will be domain. And the third one will be responder. And what I'm going to do is I'm going to keep this git keep file just in case, so that my folders are created and are in GitHub. And here in the domain, what I'm going to do is I'm going to create a new folder called services. And in here, I'm going to put the container, the one that we want to create for our purposes. Let's do file. All right, so let's have a quick look here. Before we start moving on this, I just want to make sure that we have the proper PSR loading up here. Excellent, we don't have it. So we need to give our application a namespace. Where is it going to be looking? Where will Composer be looking for our stuff? So in order for us to do this, we're going to call this namespace Phalcon/API. So in order for us to do that, we need to put the auto load section in Composer. So auto load, and then we will have PSR4. This is something we did not do in the previous video. So it will be Phalcon API, and then that one will point to SRC and then slash. And also we're going to put another one for the dev side, and then we're going to name this tests, and that one will point in the tests folder. Alright, so this is our auto load. Whenever you see Phalcon API, go and look for it in the SRC folder. Whenever you see Phalcon API tests, go into the tests folder. Alright, let's do a Composer update. Excellent. And now that we have these namespaces, now our container here should be, according to that namespace, should be namespace will be Phalcon API, and then it will be domain services, and then class container. But this container class needs to extend DI. Extend DI. This was supposed to be auto-completing, but there you go. Extends DI. Well, it was extends, not extend. Alright, so we now have this container. We need to start loading it with services. Well, the loading of the services will happen in the constructor of the DI container. construct. Now we know that the actual DI container has a services array that it keeps all the definitions. So let's do the parent construct here, and then let's do the services as follows. All right. Inside this services array, we need to define a string, and then the value of that array element will be a service definition, which will define what this service is. If you recall, on the page we got that it cannot find router, right? So at least we need to make sure that we have the router object in there. For convenience purposes, I'm going to create several constants that I can use to call services from outside this container, or referencing this container. So let me create one public const. What is this? Let's say it's going to be cache. That's going to be one. Connection, filter for sure, and then a request, response, of course, the router, and let's put a logger in there as well. Alright, so all these are nicely done, and we can add more as we go along. I'm putting these in order to satisfy PHP stand later on. Okay, so let's begin by adding one of these services. So it's gonna be self, let's say filter. Let's do this, get service filter, and the private method here, it's not returning string, it will return service, and return. What we can do is we can make it so that it is a lazy loaded service. So it's going to be a new service definition, and in this definition we're going to use an anonymous function. We'll return new filter factory, and then new instance. And what that will do is it will invoke the filter factory. It's going to pick up all the filters that are already defined in the Phalcon filter, and then return a new instance of that filter. So with this, we're going to have access to the string filter, ABS int, date, and so on and so forth, email, and whatever. Equally, after the filter, we can do the request and response. And those are going to be very easy to do because it's just a simple class. So what we're going to do here is we're going to say private function get service string class name, and then that one will return a service. And for the definition of that, will be return new service and then class name. Actually, what we also need to do is put a bool is shared equals false, and then is shared here. Get service already exists. Let's name this get service simple, and it will be just a single class name. The service class for DI offers quite a bit of flexibility in terms of defining services. So you could use the function like this, the anonymous function, which means that this is going to be resolved when the service is invoked for the first time. You can also use a class name, so you're just passing it a string, and it stores that string and whether this is shared or not. Actually, talking about shared, we're going to need to do true here because we want the filter service to be shared. So when we call it for the first time let's say at the beginning of a request, it's going to be instantiated, but any subsequent calls for that filter service later on in the request will be reusing this object. It will not be creating it again and again from scratch. So we want this filter service to be shared. The same thing with this get service simple little method that we have is we want to make sure that the services will be shared or not according to our needs. So for offering these new services into our, or defining, if you like, these services into our DI container, what we need to do is the easy ones. So self request equals this get service simple, and the class name will be a request, and it will be this one, class, and then it will be a shared service. And then let's do the response. It will be the response class. We need to put a comma here and a comma there. Alright, so far so good. 3 services registered. Let's have a look at the rest of them. We need the router, logger, connection, and cache. Connection and cache, let's just leave them for now off. We're not going to do them right now, but we will address them later on. Of course, the connection will work in conjunction with what we've done with things and access our database. But we need to do the router. And in order to do the router, we have to make sure that we have different settings for it. Just create the router itself. So let's say self router equals this get service router, and the get service router QRS, it's somewhere here, private function get service router, and we'll return a service. Let's put some doc blocks here, makes it a little bit nicer. So of course what we're going to do is return new service, and the question is, what do we put in here? We could certainly create an anonymous function like so, and return new router. It's just going to be our MVC router, and then put a false in there. And we'll get that. However, there's a different syntax, if you like, the array syntax that the DI service allows for. I'm just going to type it underneath, and we're going to use it for this service alone, just to make sure that you guys have different ways of defining services. So the different syntax is as follows: return new service, and then let's close that, And then in here we're going to have an array, and that array has specific elements that instructs the service class to do whatever it needs to do. So first of all, it's a class name, and the class name will be the router. And then if we leave it like this, it's going to be perfectly fine. It's going to return a router service. But if you see here, we're actually passing a false in the default route. So we don't want default routes to be created. And in this syntax, we need this to be passed into while it's being instantiated by the DI container. To do so, we just need to pass the argument. So the second element will be arguments, and it's going to be an array that will have the first element will be of type parameter, and then the value of that parameter will be false. So let me comment this one out for a bit so that you can see the one below. So the syntax above and below, the commented one and this one, are identical in a sense because they produce exactly the same result. In this one, we have an anonymous function and we just create a new router object with no default routes. On this one, we have an array where we say, okay, you're going to pick up the router class, and when you instantiate it, the first parameter of it on the constructor is going to be the value false. So whether you use this or whether you use this, it doesn't matter. For the purposes of this example, I'm going to leave the array implementation just to have it here. So it's different options that you guys can use. Okay, so now we have this container. We have a few services set up. So request response filter. Let's have a look if this one actually works as we expected. So we need to go back to our index, and this container equals new DI, we need to change it to container equals new container. And now let's have a look what this one will bring. Alright, so now it tells me that I have a not found handler, or it's not defined or it's not a callable. And this is typical of the micro application because it expects to have routes as well as the non-found handler. So let's correct that. Going back to our project, and we just need to define it. So let me just copy this line here just to have it. And what we're going to do is, let's put the routes a little bit above here. Application not found, and that one will be a function, and then in that one we're going to say 404 not found, and then we're going to put a date to it as well, just in case. So we're telling the micro application your not found handler, and now I can get rid of this, your not found handler will echo this. So now if I go back to my browser and I click on refresh, you see it gives me a 404 not found. And of course, the more you refresh it, the numbers change, the date changes. Naturally, that's not the only thing that we want to do. We want to expand this. So let's create another route, because what it does is it fires the not found router because there's no route defined for our slash, the initial route. So let's create a route for this, and let's define it rather as application get. And what we're going to do is the verb is get, so we're just gonna get a page. Then what we need to do is we need to use the pattern, which will be slash, and then what it's gonna do when we get to that point. So that one would also be a function, and then on that let's go with good old echo. And this one will be hello world. Put 3 exclamation points. So now if we go back and we refresh, now we have hello world because we did a get and the URL is the slash, the root URL, and that one actually creates the hello world. So this piece of code gets executed when we refresh the page. Now if we go back to the browser and put /user, for instance, we're gonna see a 404 because that route does not exist. We mentioned that in the ADR pattern, the action domain control, the action domain responder, the responder pretty much picks up some certain things and just spits them out on screen according to what is required of the application, what kind of format you want it. So what we're going to do is we're going to create a brand new responder, and we're going to tie it up here so that it responds back to what we want, right? So let's have a look. Let's create a new class. In order to create it, before we create a new class, let's call this action hello. So this is going to be our hello class, and then from then on we're going to have different responders. So directory hello. For this example, we're going to create a text responder, and let's call it hello text responder. And what we're going to do is let's copy this doc block, paste it, the namespace will be Phalcon API, and it's gonna be responder, and actually it's gonna be hello, and then it's gonna be final class hello text responder and public function invoke. And then what we're gonna do is, for now, we can just put string payload. Actually, this method should not return a string, it should return actually a response. And in order for us to return the response, we have to get it. So what we're going to do is public function construct response equals response, and we can make this private and keep it there. And for this one, this response set content equals payload, return this response. So this way we're going to get a payload here, set it as a content in the response, and then return the response. For the index.php, what we need to do is we need to get this response and then send it back. All right, so how do we do that? Remember, in the container, in this class here, we created our response class here based on this. So if we go back here, what we need to do in the index is we need to use container, and then here from the container, response equals container get, make use of the constants. All right, now we need to do responder equals new hello text responder, and then in here we need to put the response, and then how should we call this? Again, response. I don't like it, so let's say output response equals responder. This one actually calls it, but that one expects something. So what we're going to do is we're going to send it a string. This is our string. And now what we need to do is, since the output response is of response object, output response send. So it will send the response. This object here, the response, is the Phalcon response object. We're just picking it up from the container. We're creating a brand new responder, and we're passing that response in there. We're calling the responder. This one hits the invoke method, and we're sending a string into that. And then once everything is done, we get our response back, and then that response is sent. Okay, so if we go back to Brave and we refresh, we're actually getting results back. So our code works just fine. By making a slight change from simple echo to now use the response object and a responder, we managed to do all this work for us. Now, as far as the content is concerned, what would the responder pick up from here? It's just a static text, but the content that the responder will receive will have to come from the domain. So what we need to do now is we need to create a new service in the domain folder to create the content for us. So let me come up here and copy this little doc block, and in the domain I'm going to create a new directory called hello, and in here we're going to create hello service, and let's just paste this. It's Phalcon API domain hello and class hello service. And what we need to do with this hello service is to actually call the necessary logic, and whatever that logic is will return something, and that something will be sent to the responder. So in our case, if we look at the index, we just need this guy here, just the hello world. So let's copy it, and the hello service invoke. Yes, it will return a string, and we just need to do return and this. Very simple, nothing crazy. We're just calling invoke and then a string. Of course, as the application keeps on growing, you will be required to inject more services into your service from the DI or different objects, and perhaps different parameters into your invoke. So what we need now is we need to get this and tie it with what we already have. So in this example, in this piece of code here, if we are to put the hello service into play, what we need to do is we need to create it. New hello service. Alright, we created our responder, and the output response will be responder service and that. So this here is going to call invoke on the service, and then this one will call invoke on the responder. So what we're doing is, actually let me split that out. So service output equals service, and then there you go. It's a little bit clearer this way. So we're picking up whatever service calls, whatever service does, and then we're sending it to the responder. And if we go back to the browser and we refresh, we keep on getting different times. So this code is working. Of course, we will need to do testing with this, and that's going to be the next video. But just to complete this whole scenario here, what we need to do is we need to pass all this to the action, or we need to have the action rather, in order to allow us to do this routing that we discussed earlier. So the action will get will be called upon matching of the route. It would be responsible for calling the service, getting the results back, throwing it into the responder, and then the responder will send the response out. Okay. So let's create this service, this action rather. Let me go up here and just copy this. And under action, what we're going to do is we're going to create a folder, hello, and then of course we're going to create hello action. And actually, it's not going to be hello action, it's going to be a get action. So what we're going to do is we're going to specify the verb into the name of the file. So the action will be hello, what we want to get, and then it's going to be a get action. If we had a post verb, it would have been a post action, and so on and so forth. So let's paste this one, and then final class get action and public function invoke, and then close that. For now it will be void, it won't do anything. So what is the get action supposed to be doing? Let's have a look at the index.php. Well, pretty much it needs to do this whole thing. It needs to pick up the create the service, or pick it up and then create the responder, and then do all the work that we need to do. But if I get all this and paste it in the get action, then I'm missing the container to get the response, which is not really good. So what I will need to do is I'll need to inject the response into this class, and that's the way that it's going to be able to do everything. So let's do that. And let's name this private. Now I have the response here, and I can do this response. And then it's going to send everything back. So what changes do we need to make to our index.php now that we have the action? All right, we got the container. We need to call action equals new get service. Get action. And then we need to pass the response. And then we need to actually call the action. And this one will create the invoke. It will actually call the invoke. So now if we go back to the browser and we refresh, we're still getting numbers back from the date, which means that our code is working. Now here's a problem though. The hello service just does some work. Everything is in the domain and everything is fine. With the get action, we do have some work done here, meaning the routing, but we also have the send, which is not supposed to be here. The send is the responsibility of the responder. And also we have the new service being created here and another responder being created there. So if I were to test this method, it would not go well because I cannot individually create those two services and mock them in order to produce different responses and results that would allow me to test different paths of my application. So the best way to do this is if I have the hello service and hello text responder as constructor arguments, meaning I have these services injected. So let's have a look at this. What we need to do is we need to put hello service, and that will be the service, and then hello text responder equals the responder. And I can do these private, read only, and I don't really need the response because the response is to create the hello text responder. So all I will need from here is to get rid of these two and then say this service and then this responder with the service output. No, it's not going to work on this. Actually, we'll have to wrap it in these curly braces, and that should make it work, I think. All right, let's go the easy route. Service equals this service. Responder equals this responder, and then we can call them like this. We will tidy this a little bit later. It's not a big deal. So we just got these guys injected in here and we're calling them. And of course we need to get rid of this send. The send will have to end up in the responder part. So for now, let's leave it here, and then we're going to go back to the responder. So how are we going to create this object now from our index.php? Okay, well, the get action no longer needs our response. It actually needs the service and the responder. So what we need to do is, again, service equals new hello service, and responder equals new hello text responder, and then response in here. So this one will need to take service and responder. So this is how we managed to change it. We go back, refresh, it keeps on sending numbers to us. Okay. For me to do all this work, it's a little bit mundane and difficult because I'm gonna start having more and more and more routes, and it's not gonna help me. I will have to increase the definition of the routes, and it will be a lot of copying and pasting, and it will be a lot of replicating this particular example to keep on moving it to different routes and so on and so forth, because now we have the slash route. Later on we're going to have probably an add and edit and so on and so forth for the users, and the same thing for companies and whatnot. So in order for us to get this thing to work, we're gonna to work better for us, what we're going to do is we're going to use the DI container in order to encapsulate all of these in one go. Here on in the DI container, what we're going to do is we're going to create the necessary services to actually get the DI container to create those objects for us. So let's put a couple of constants here. Action equals hello action. A service and hello responder text. All right. So these things, these are going to be my keys, how I'm going to be calling the services themselves. That's the service. And their registration will come down here. Let's leave that there. And hello responder text. Okay. So the action one requires the service and the responder as parameters in the constructor. The service is plain and simple, it just doesn't request anything, and the responder requires the response. So for the service, what we're going to do is we're going to utilize the get service simple method. Simple. And it's the hello class, then we make it shared. Let me just put these down so that we can see it a little bit better. The responder would be this get service hello responder text. That's how we're going to name our method. And for the action, it will be this get service hello action. Let me copy these for now and then go kind of like at the bottom. I want to be below this method here because I want to show you a different way of adding things. So the first method will be private function, will be that, and that one will return a service. And then the next method will be private function, will be this down here, service, and then return that. Okay, so for the responder, let's start with that for now. We need to create a new service and we need to inject the response. The response already exists as a definition in the DI container. So what we can do is we can either utilize the anonymous function, that's also going to be lazy loaded, or we can use the array format by using the service parameter as the type of the injected variable. And let me demonstrate how we can do that. It's extremely easy. So let's see the initial approach, how we could do this using an anonymous function. So for the hello responder text, we need the response first, right? So response equals this get self response, and then we're going to return a new service, which will be function use response, and then return new hello text responder and response. So that is the definition that I would use if I were using anonymous functions. If I'm not, which I'm trying not to right now, let me just comment this out for a minute. What I'm going to do is I'm going to return a new service using the array format according to what we have above. So just like the one above, what we need to do is we need to do class name, and the class name will be hello text responder class. And then of course we're going to need arguments, because remember we need to inject the response in it. So the first argument would be of type, and it's not going to be parameter this time. This time it's going to be service. And the name of that service will be the name that we gave it in this container. So container hello container, actually not even container, self response. So these are these two snippets of code do exactly the same thing. The one here, the one below, that I have commented out, use the anonymous function, picks up the response from the container, passes it into the anonymous function, and then creates the new object with the response. This one is a little bit more, it's a little bit different, where you just send an array into the service definition and you just tell it, I want you to create this hello service responder, and then I want you to search in your services definition for this actual class, and once you have it, then you're going to inject it in the constructor of this class. So let's use that second way of defining things, and this is how we're going to get the responder. And of course, now that we have this guy over here, we can do the same thing for the action, and in this case it's not going to be the hello text responder. In this case it's going to be hello action. Actually it's the get action, and then class, and the arguments, they're going to be both services because we have defined them as services. If you recall, up here we defined this one, and this one as services, so the DI container knows which ones they are. And here in the hello action, what we need to do is first we need to pass the hello service, and then the second one is the hello responder text. So hello service, hello responder text. So when we call this, when we tell the DI container, give me the hello get action, it's going to come over here and it's going to look at this definition and it says, okay, it's this class over here, the get action. But in order for me to create the get action class, I need to inject the hello service and the hello responder text objects in it. Alright, let me go and see the hello service. Nothing to it, is just a service, just a simple definition. Let me create it. So it creates it. And then when it goes to the hello responder text, it actually comes down here and it says, oh, it's this class, but this class requires the response object. So it goes and picks up the response, which is already defined, and if it's not created, it instantiates it, and then it injects it in the hello responder, and then it returns it back. And as such, both of these parameters have been injected, and you get back the class action. What we're going to do is we're going to make this one. I don't think we should make it shared. There's no reason really, because these are not going to be called more than once in the same response. If we see that we need it later on, of course we're going to do it. But for now, we can just keep them as they are. And having said that, this hello service, this class doesn't need to be shared, so we just leave it like that. So now that we have these three, the action, the service, and the responder text defined in our DI container, going back to our index, we can do things a little bit different, because now what we can do is just say action equals container get, and then container hello action, get rid of this, get rid of this, get rid of this, and then just call the action. So we've delegated the creation of all the necessary objects that are required for this action to the DI container. When the DI container requests this particular service, it will go down here. It will start by creating this, but before it does, it's going to create the hello service because it's a service. Then it's going to create the hello responder text, and reminder, it's going to inject the response into it. And then once everything is done, it's going to return it back to us, and then we can call the action. And if we go back to the browser and we run, it runs perfectly fine. So this way we manage to utilize the DI container to do a lot of the work for us, and then we can certainly replicate this for other actions. The last thing that we can do is, now that we have some sort of uniformity in the way we have in the routes, we can translate this particular route to an array. And here's how to, and how what the benefits would be. All right, let me delete these because we don't need these imports. So the routes would be defined as follows. So we're going to have, first of all, we need the method. And the method is going to be lowercase get. The pattern will be slash. And now the action, or the handler, does not need to be a function. It needs to be the name of the service. And that one will be this. So let's have a quick look how this helps us. If you notice, in this definition here, we have a verb, we have the pattern here, and then we have the execution, the handler. But if you look at it, we're calling the invoke method on it, and the only thing that we do here is we're picking up a service from the DI container. So what we have here can easily be rewritten. Let me just clone it and keep it down there as follows. So method equals method, pattern equals pattern, and handler equals handler. And all we will need now to do is to define this. So application, now we're going to need $method, $pattern, and then we're going to have function, just like below, use container and handler, And what we're going to do is action equals container get handler, and then action. So if you notice, this piece of code is pretty much identical to the one below it. So we have dollar method here. Here we have get. We have dollar pattern here. Here we have this parameter, this pattern. And then in the function itself, we have container get the handler, which is this variable here, and then call the action, the invoke. And all these come from this array, and they get translated exactly in the same manner. So if I delete this one and this one right now, and I go back to Brave and I refresh, I keep on getting the time changing, so the code executes as expected. But now I can create an array of all these routes and make it so that whenever I need to add a new route, I just add a new element in the array, and then this code would make sure that it is executing the way it's supposed to, and matching, of course. So I could have a post method, a get method, the pattern could be /user, /get, /whatever, and all of them will be mapping to the relevant service. And the DI container is going to be doing all the dirty work for me by creating and instantiating all the objects that we need to instantiate. So this we're going to wrap it here. We're going to stop here. We're going to have another session later on where we expand on these on this methodology, and we're going to start querying the database later on, and so on and so forth. So I hope you got a little bit of a glimpse of how things could do, how you can use the container to your benefit to make it work for you. This is not 100% auto wiring, as it's been discussed in different books and all that stuff, but what you do is you allow the container to create objects for you for services that you have already defined in your in that container. So you don't have to do a lot of this new, pass this variable, and so on and so forth. And whenever you do need to change the definitions or the injected services to whichever class you have, then your routes do not change, because the parameter for the handler is the action, and anything after that happens in the DI container. So your main code doesn't change, you just change things in the container, and everything changes with that. And with that, thank you so much for tuning in. We will have another one very shortly. Take care.